Dear learner, till our previous lecture, we have done many things about that model. So now we'll start designing beam from ETABS result. Okay, so it's very important to design a beam perfectly with proper guideline. So let's start. Now to design beam, first of all, we have to already have analyzed our model. You know that. Then we'll go for design. So to design, we'll click here. You already know about it. Then the most important thing is first we'll go here, view or revised preferences, and here you have to change everything. How do you need to change? Design code, then everything available here, seismic design category. Okay, so I'm not going to change anything. I'll take every value as a default because I'm selecting ACI 31819. Then I'll click OK. And I'll click here and select design combo. This is the most important thing. So to select design combo, I'll select all of the combo we have created in a previous lecture. If you're new here, you may able to watch that, okay, from our complete course. Select and then click OK. So 23 load combination we have added. Then I'll simply click here, or by clicking here you'll get the option start design, or check even by clicking here design, then concrete frame design, you are able to find out that. So let's click here start design or check. And actually if you use that option, you know previously have used concrete slab design to design all types of slab. Then now we are going to design this option, concrete frame design. So if we use that option concrete frame design, only our beam and column will be designed. I'll click here and start design or design check and wait for some time. It will start designing our model. See, our design have been completed. Now first of all, to check our all design criteria, okay, I'll go here, plan view, or we may able to select that it's this set, plan view, and go to, let's say, ground floor. Okay, and click here and display design info. From here, what you want to see: design output, total longitudinal reinforcing, total river percentage, shear reinforcing, column ppm interaction ratio, then joint shear capacity ratio, every data available here, flexural longitudinal reinforcing, and here total reinforcing. Okay, so I'll click, first of all I'll click here flexural or identify all failure. I'll click here to identify all failure to check our beam that it's failing or not. Click apply. I'll go top. So here we are seeing no beam are failing at this time. I'll discuss about that, why it's not failing. See here we're getting two beam failing, seeing the red color. So if you take mouse, or you may see the value of V, that means it's failing on shear. Here also V, here also VV. So that means these steps of beam are failing on shear. I'll go up again. Here also more beam are failing. Again I'll go top. Here also a beam added in our failing list. Okay, so in this way you have to check on which story, which beam are failing. Now the portion is how we can change it, our failing mode, or how we can modify beam to solve that fail. I'll click OK, apply. Okay, then select that beam and right click. You will see for which region these beam are failing. Now you may see here overstress 45. So what is the meaning of that? Overstress 45 means if we go here for design and see shear stress due to shear force and torsion together exist maximum allowed. That means our shear stress, allowable shear stress, is more than our developed shear stress. That's why our this member are failing. So how we can solve that? We all know that to solve a beam that are failing in shear, we have to increase our beam size. Okay, otherwise we have to neglect our torsion. If we come here over it, and here beam we have taken 12 into 22. If we have the beam size more than that, so 12 into 20 inch beam is the maximum beam size already have provided. Now if we change here, let's say if we do not consider any torsion for that beam, then what's happened? Click OK and see our that beam are passing. So for no torsion, our beam are passing. Now you have to take a critical decision here. How much beam are failing? That's the most important thing, that how much beam are failing. If the failing of your beam are very less, or less number of beam are failing, then we are able to ignore these types of failure for torsion only, not for shear. For shear, your beam must be passed. Okay, but if you see that the most of your beam are failing, then must you have to consider that. Now first of all, as these beam are failing, I will show you only all beam modification system, then you have to work on it. I'll uncheck it, I'll click OK. As this beam is failing, so I'll go here and define section properties, frame section, then beam, we have taken that beam, take copy of property. I will increase our beam size little bit. Let's say 25, 12 into 25, 12 into 25. And if you come here for rectangle, okay, no need to change anything from here. So let's check for that beam. So I'll change the beam name, let's say B2. Close it, and I'll select this beam. I'll go here assign, I'll go here frame, then what we will assign? Section properties. Which one? From where is your B2 actually? Sorry, again I'll go here. Maybe I didn't OK it. Sorry, I didn't OK it. I cancel it. So I'll click here, add copy of properties, take its name, let's say B2 25, then 25, OK, and must click here OK, otherwise you'll lose it. So again have selected, then go assign frame, then section properties, let's say B2, apply, OK. Safety here we have B1, but here we have provided B2. Let's check again that is it okay or not. So I'll click here run. So when our analysis is done, I'll click here and click start design or check again, and we'll see what happened. So I'll go here, design show display, then identify all failure, click here, apply. See, still our this beam are not passing. Okay, our beam are not passing. We have taken 12 into 25. I'll just go here. Now our shear force and reinforcement for shear increased little bit, 20.67. okay, and here shear for steel 0 and shear P, total shear actually. So this is 11.15. Now what we can do actually here, we may able to ignore it at this time. Why? Because if we go manual calculation for that required river, then we will be able to provide the stirrup, or will be able to provide stirrup as per required. Okay, now the question is, if you see here, shear for S, that means steel, the developed shear for steel, as will provide steel, that means must will provide the shear for that steel. Okay, but here it's showing us 0. Why it's showing us 0? Because we didn't provide any shear actually. Okay, so what we can do that, what we can do here now, we can go for manual calculation for that. So in our another lecture, I'll go for manual calculation. In this lecture, I'm going to show you that how we can design a beam as it's failing for shear. Now we'll ignore for shear, we'll go for longitudinal reinforcement, as our beam is not failing for longitudinal reinforcement. So I'll click here and we'll see the option flexural longitudinal reinforcement. I'll click here, then I'll click apply. You must see this is the value of flexural reinforcement. So here we are seeing that for top left side, our maximum reinforcement are showing 0.75 on 4. Everywhere it's showing the minimum reinforcement 0.75 on 4. Why it's showing? Because the section we have taken, this is actually not necessary for longitudinal reinforcement. If I take our mouse here, we may see here different reinforcement in different position, but here 0.65 2 on are the minimum reinforcement as per ACI code. So how we can check it? If I come here, we have a design parameter Excel sheet. Already I have provided that Excel sheet, please check it. Then if you want to check about minimum river calculation, so here provide minimum river calculation, here provide the FI you have provided 72.5 KSI, it's okay. Then beam size, 12 into 22, and here the concrete we have provided 4000. Now see here the minimum reinforcement are required 0.655, and the I mean in our advanced version it's already calculating that 0.06521. That means no need to tense about your design. The software will give you the maximum valuable value here. Now if you go for designing, first of all, what you have to do, you have to, let's say your all of design is okay, I'll request you to change that section. Already I have taken. I'll not change this at this time, because if I change it, it will take again it will take more time. So suppose I'll design beam from here. Now what we'll do actually, to design beam, first of all we have to create some group. So why grouping? Because as here we have provided beam size as a 12 into 22 inch, but every time we may not provide it. When we'll go for the actual project work, we'll provide different beam size as per our architect, and if it's gonna fail, we may change it by consulting them. But here we don't know, so what will be the actual beam size? Then I have taken a random size, and I'm seeing every section are passing. So here we're seeing this value are in very less, I mean very low. So what I can do, we can go here option, then graphics preferences, then here the maximum font size 8 and minimum graphing font size 3. So if I take it 5 points, sorry, if I take 5, then click OK, see it's increased here, it's increased little bit, our font size increase little bit. Again, if you go here to change it, so let's say font 12 and it will be 8. Click OK. It's also increasing the size. In this way, you are able to change its size as per your requirement. Now, what we'll do actually, we'll go for our next step. Okay. See here, let's say first of all we'll group some beam. We may take the beam size, we may take the group for longitudinal reinforcement also, the torsional reinforcement also. So if I take the reinforcement, if I click here for torsional reinforcement, see we are seeing that almost for maximum beam we need torsional reinforcement. See, almost for every reinforcement we need torsional reinforcement. So what I can do now, what we can do now, we are also able to take grouping for that. Sometimes you'll see some beam are not required torsional reinforcement. So let's say here one beam are not required torsional reinforcement, but except that beam, every beam need torsional reinforcement. So what we can do, we can ignore the grouping system as per torsional reinforcement, because when we'll see the almost majority % of beam not require torsional reinforcement and majority % of beam require torsional reinforcement, then we may go for that some beam require torsional reinforcement and some beam not required also torsional reinforcement. So now what we can do, suppose the beam are in that direction, in X direction, we'll take one group, and beam are in this direction, we'll take as another group. So what we'll do, first of all, we'll see that how much maximum reinforcement required for top left in on a specific beam or in on a specific position. So here, if we see here, we need 0.828 for torsional reinforcement. I will go for flexural reinforcement, and we have another option, total longitudinal reinforcing. So if you take that option, you no need to calculate or you no need to tense about torsional reinforcement or longitudinal torsional reinforcement or main or flexural longitudinal reinforcement. I'll click apply. See here, every beam are showing us the actual requirement of our beam. So if I go here for torsional longitudinal reinforcement, that was 0.82, the flexural that is 0.75. so if you come here, you may see this is actually nothing but total summation of longitudinal reinforcement and torsional reinforcement. So I'll take this option, I'll take this option as a longitudinal reinforcement, but as this is a big span and also we are taking here we are getting here more reinforcement, then we may ignore that beam to make grouping same as that beam. Because see here we need 0.80 inches for reinforcement, but here we need 1.52 inches square reinforcement, almost double. So is it okay to use same reinforcement here as we are getting from that reinforcement, that beam? So it's not. So what we'll do, we'll take that 4 beam to make a group, and for that beam we'll make another group. Is it okay to you? So suppose how I'll do it, first of all I'll go for top left side, top left reinforcement. I mean I int top, it is 0.80, 0.90, 0.87, 0.77. so I'll take the maximum one, 0.90. I'll come here, final top river, what is it, 90. Then I'll go for the right side, maximum right side. So here 0.79, 9 on, 89 and 79. So we'll take 9 on, right, the maximum one from your group. Then we'll go for I bottom or left side of bottom. So I bottom, that is 65, 69, 67, 67. So we'll take, let's say 0.68, 0.68. And for right side 66, 69, 69. Okay, let's say 0.7. Now we'll go for middle. The maximum values in our middle are 0.78. Total reinforcement. And the top of our middle, top middle, 65, 66, 66, 65. Let's say 67. And here this is the option for providing torsional reinforcement. As we are getting torsion plus long reinforcement here, so no need to provide here anything. If you calculate your torsional reinforcement separately, as but by using that software you will not be able to do it. You have to use the lower version or the ETABS 2016 version. Already have created video on it, you may be able to watch it, because there it's provide the reinforcement for your top, and also but for this beam, this software or this advanced software, it's automatically provided every value you need. Okay, so here we got all required value we need to design that section for longitudinal reinforcement. Now I'll go here. Now I'll take decision that how I will design this section. Let's say, so here we need 0.9 inch reinforcement, here also 0.9 inch, but here we need 0.67 inch reinforcement. So if we provide two 60 mm rebar, we'll get 0.639, okay, 0.63 inches square reinforcement, but we need 0.67. that means it's the less than we required. So if we provide 3 reinforcement here, 3 reinforcement, then we'll get 0.93, but here it's not required. But if we go for left side and right side, we need 0.91 inches square. So actually here nothing to do, because we're not able to provide 0.63 inches square, or it's less than 0.67, and again we're not able to provide not less than 0.91 inches square. So what we can do here, actually we can provide here 3, let's say 3 16 mm top river, 3 16 mm top middle, and take that reinforcement here. And for bottom we need here 0.78, in that side 0.7 and that side 0.68. so again here we are not able to provide the to 16 mm reinforcement. So what we have to do, we have to provide here 3 16 mm rebar. Now you may tell me, so is it okay to if we provide two 20 mm rebar, we will get 0.79 inches square. But if you provide, when you need you are able to provide also 2 20 mm rebar or 3 16 mm rebar, I'll suggest you to use 3 16 mm rebar. Why? Because it will make your structure economical. Let's say how. If you come here, suppose if we provide 20 mm 3 nose bar and 16 mm 2 nose and 16 and 3 nose bar, and the total length, the let's say a same length, we'll use same length because almost we are getting where we will provide 20 mm, where we will provide 30 mm, the length will be same, right? So let's say 500 feet and 500 feet. Okay. So if we take here the taka or any value you use, let's say, so what will happen actually? See what will happen here, the total weight we are getting, length, and the here I have provided the value of something. So we are seeing that for that for that very basic difference, for 500 feet length, we are getting 66,200 taka difference. Okay, so in this way you have to think as an engineer how we can do it, So I think it's okay, but it's up to you. Done. In this way we are able to design for our beam. Okay, now we'll go for shared design. So how we'll go for shared design? Let's do it. So here, detailing river, shear reinforcement calculation for beam. I'll go shear steel calculation, and here as per ACI code, I'll provide here the width of beam. Let's say 12, it's 22. And which types of frame we have selected? We have selected a special moment resisting frame. What is the value of FY? Effective covering. We have provided 2.3. You will take that effective covering, or you have to provide that effective covering as per we have already have calculated. Then leg number. So what is the leg number? This is the leg of our stirrup. That means if you use U type stirrup, then you have to use 2 leg. Then required shear rebar. So required shear rebar means, so how much shear reinforcement we need? I'll go to software. I'll go here. Then here shear reinforcing. Okay. Then apply. You'll see here everywhere the shear reinforcement it is giving, and also if we go here, shear plus torsion reinforcing. Apply. So here we are getting the shear plus torsion reinforcement. Now we'll see the maximum shear reinforcement we require. Let's say 0.73. Okay, so I'll provide here 0.73, and the bar you want to use, die of shear bar. Let's say if we provide 20 mm bar, or if you provide 10 mm bar, it's up to you. And also a smallest die of long bar. So what is the smallest die of a long bar? We know 16 mm. So here as per code you will get all of that option, and here in left side we have to provide a spacing for 4.75, right side 4.75, at middle 5.76, that means 5.75. And if you provide 16 mm bar, sorry, if you provide 10 mm bar, then here 4.00 inch spacing reinforcement required as per design. For design, this is for design requirement. so it's also 4, so you have to provide 4-inch spacing reinforcement everywhere. Okay, so I'll recommend you to use 12 mm. This is the way to use our longitudinal reinforcement as a shear and torsion, flexural and torsion, shear reinforcement as a flexural and torsion, shear and torsion. So I think you'll be able to understand on it that how we can design it. And the first thing I have told you that we may go for manual calculation. How we'll go for manual calculation? Let's say from here we'll take the section. Let's say how much section we have taken here. We have taken section for 12 into 22. Then we'll go here for here, and from here for the combo, for which combo we are getting the critical situation. From here you have to take it, right click, let's close it, right click, and here you will see for which combo you are getting. Mainly 6.4 combo 6.4 we are getting 6.4 we are getting failing. Okay, so I'll close it. I'll come here for combo. From here we'll take 6.4. Let's say maximum value or max, and for moment 33 here we'll get our maximum moment. So for that maximum moment we're able to also show value. So as per that value we're also able to design our that section. Now we'll go for shear 22. See here, this is the value for shear 22 minus 19.32, and in that side we are getting 21.62. And for that shear simply we'll go for design. Okay, so I'll try to create another video on it, that how we can go for manual design, because if we go for manual design, then with limited section we'll be able to design that beam. So thank you very much. Stay connected till next lecture.